Okay, we're not talking about functions defined piecewise. Now I want to take a look at some homework problems, and I'm going to share my screen, and we're doing some math modeling here. We're going to find functions to model certain given situations. So if I share my screen, we're going to go to, now it says homework 2.4. That's not actually your homework, but I've taken an excerpt from your homework. And so it covers section 2.4 here. All right, so the first question says, to convert a temperature from degrees Celsius to Fahrenheit. So the Fahrenheit depends on what the Celsius is. We're inputting a Celsius to get an output of Fahrenheit. And we are told that what you do is you multiply the temperature in degrees Celsius by 1.8, and then you add 32 to the result. So if you look at your choices here, F is your function, and you're inputting a Celsius, that's the C. And what you do is you take 1.8 times that Celsius, and you add 32. So C describes that perfectly. So we're just looking for linear functions that describe the verbal, that give the situation verbally. All right. So here we have another verbal description. We're looking for a symbolic representation of that. And we have an object that is dropped off of a tower, and the velocity V depends on the time in seconds that the object is falling. So at the point that the object is dropped, T equals 0. And it says that it can be tamed by taking 32 and multiplying T by 32 and adding 10 to the result. And we're expressing V as a linear function of T. So V depends on T. So it just says you take T, multiply it by 32 and add 10. And you can see the top equation is the description there that we're looking for. Here, if an object is dropped from a tower, then the velocity now in feet per second of the object after T seconds can be obtained by multiplying T by 32 and adding 10 to the result. Find V as a linear function of T and use this function to evaluate V of 1.3. So we're taking 32 times 1.3. I'm going to use my calculator to do that. So 32 times 1.3, and then it says you add 10 to that result, and you get 51.6. So that is in feet per second. So there's our answer. All right, and in a certain city, the cost of a taxi ride is computed as follows. There's a fixed charge of $2.95. That's your start. That's when you've gone 0 miles. And for each additional mile, it's $2.40. So you're going to take, for each mile, you're going to multiply that by 240 to get, but then you're going to add the $2.95 because when you haven't gone anywhere, you have to start with $2.95, even when X is 0. So here you can see we're starting with $2.95 and adding 240X, so A is the correct choice. Finally, we have a company, a shirt and jacket company is producing a new line of jackets, and there's a fixed cost of $580. Then it's $30 per jacket to produce. So we're going to find the total cost of the producing X jackets. So again, you start with 580, and then for each jacket, you take the number of jackets and multiply by 30, because for each jacket, you're spending $30 plus the initial cost of 580. So you can see the top equation models that perfectly. And there you have it.